how to predict products, right? We're gonna learn a couple of the equations, not the whole thing, right? So here we are with our types of chemical reactions, right? These should all look familiar. We learned these the other day. Combination or synthesis, we have two singles and they become a couple. Decomposition is the opposite. The couple breaks up into two singles. Single replacement, single couple, right, become the opposite. Almost like this guy, right, got a new girlfriend, basically. Double replacement, both couples swap. It's very Midsummer Night's Dream if you guys are Shakespeare fans. And then we have a combustion reaction at the end where everything is permanent, right? So that should all be familiar. So today we are going to learn how to predict products, right? So what happens if you don't know this side of the equation? And we need to do this because this is often what happens in chemistry. Right? We know what we start with, we know the reactants, but we don't know what we might get, or we want to make sure that we're going to get the correct thing. Okay, and there are some steps to this, right? So the first step is to recognize the type of reaction, and this is actually really important. That's why we started with that lesson last time, right? So you need to be able to recognize the type of reaction before you can predict the products. And the second step is writing in the charges, right? So this should sound a little bit familiar. So if we have something like, let me turn this on, something like oxygen, I know that oxygen's charge is -2, right? How do I know that? So let's go ahead and take a look. We're just gonna jump over to our periodic table, right, which I have included with the charges, right? And if you remember, these should be written into your own periodic table, though you might not have that, right? So we have the charges up here. And over here we have oxygen. And we know that oxygen's charge is -2, right? That's how we know that oxygen's charge is -2. And bromine's charge is -1. And aluminum's charge is +3. Remember that we do not know all of these. These are unknown, right? But that's okay. We'll be able to figure them out. Okay, so that's just a reminder on where to find the charge. And I will include this periodic table with the charges written in. That's no problem. So let's jump back to our steps. Right, so we recognize the type of reaction, we write in the charge, then we're going to predict the product, make sure the charges are balanced, and then make sure the entire equation is balanced. So make sure you write these steps down in your notes, and we're going to work through some examples. So we're starting with our synthesis reactions or combination reactions, right? We want to remember how to recognize it. Two singles become a couple, right? So we're going to practice how to do this, right? So we're starting, okay, with step 1. So step 1 has been done for us already. We know that the reaction type is synthesis reaction, but we could easily figure that out because we have two singles, right? Calcium and oxygen. So step 2 is to write in the charges of these things, right? So step 2, calcium has a 2+ charge. 2+ charge. I'm just going to write, hold on. Let's see this. Oxygen. Calcium has a 2+ charge. And oxygen has a 2- charge. So that's step 2, writing in the charges. Then we're going to predict the product. We know that these things are going to combine together, right? Because it's a synthesis equation. So it's going to be calcium, oxygen. That's step 3. And now we need to make sure that those charges are balanced, right? Because this is really calcium, oxygen, and then this calcium has a little 2+, and our oxygen has a little 2+, or 2-, right? So luckily, these things are totally balanced, right? This 2 here. We crisscross, just like with our naming, right? So we crisscross our charges. And we get calcium 2, oxygen 2, right? So that's step 4. We've balanced our charges, right? We wrote in our charges that we found from over here, and then we crisscross them for our final product. Now, this can be simplified, right, to calcium, oxygen, because these 2's, right, cancel out because they're the same. We can simplify this equation to calcium, oxygen. So our final equation ends up being calcium plus oxygen goes into calcium, oxygen, right? So you could leave the 2's there if you really wanted, but it's just simpler to write this, right? Because both of these can be simplified down to 1, right? So eventually we get calcium, oxygen. Calcium and oxygen come together to form calcium oxide, right? And we just want to make sure that equation is balanced. We have 1 calcium on both sides and 1 oxygen on both sides, so it is balanced. So we are done, and this is what you would write for your final product. Okay, so let's try another one of these synthesis reactions. So again, our type of reaction for step 1 has been determined for us. It's a synthesis reaction, but we know it's a synthesis reaction because single, single, couple, right? Okay, and then step 2 is to determine the charges. So the charge on copper, we don't actually know that, right? We do know that the charge on sulfur is -2, I believe. Yes. So to figure out copper, they actually gave us a little hint over here in the products. This 2, this Roman numeral 2, tells us that copper's charge is going to be +2. We know it's positive, right, because all those middle elements are going to be positive. They're metals. They're going to be positive ions. Sulfur is going to be negative, right, because it's not a metal. Okay, so we've done step 2. So step 3 is to figure out the basic equation, right? So nothing's really balanced yet. We're just trying to figure out the basic equation. So we have copper plus sulfur goes into CuS, right? So that's our basic equation. And then we want to make sure our charges are balanced. So we have our Cu. I'm going to draw this a little Cu S let me actually draw this over here. Cu plus sulfur, and we're going to crisscross those charges. So I'm going to write them in. +2 minus 2. They're going to get crisscrossed, right? So this should be really similar from the naming part, right? So we're going to, whoop, didn't want to do that. We're going to draw a little arrow, and that becomes Cu2S2, right? It's not going to let me do that in the text, so let me write that, sorry. So this becomes Cu2S2, right? Because sulfur's negative charge went down over here, and copper's +2 charge went down over here to be a 2. Okay, so now you can simplify that like we did with calcium and oxygen just to be Cus. But let's leave it this time just for a change of pace so I can show you the balance equation, right? So we have Cu plus S turns into Cu2S. Oh, I hate that I can't write that. Okay. Cu2S2. And this is not balanced, right? Because we have 2 Cus and 2 S's on this side and only 1 on each of these. So the final equation when you balance it would be 2 Cu plus 2 plus sulfur turns into, this is an S, not a 5, turns into Cu2. Right. So that is our final product, or our final equation. All balanced, charges balanced, equations balanced. If you wanted to simplify this down, right, to just 1 on each side, which you can do, then your final equation would just be Cu plus S equals CuS, right? Copper sulfide. The reason you can simplify it is because 2 is the same as 2, right? So you can simplify both those numbers down to maintain that same ratio of a 1-to-1, right? 1-to-1 is the same thing as 2-to-2, right? So it's the same ratio, so you can simplify that down. Okay, so those are your synthesis reactions. If this whole simplification thing confuses you, you can totally just leave it as is and balance your equation, right? That's totally fine. Okay, so now we are going to start our decompositions. And I want to encourage you guys, make sure you're putting these examples into the note sheet, right? Oh, okay. So now we're going to do decomposition, which is just the opposite. You're starting with one thing, you're splitting it apart, right? The couple is breaking up. Okay, so we're going to practice this just like the others. So for this, right, this is barium CO3. So the first thing to recognize here, this, because it's in parentheses, is a polyatomic, right? So we have our decomposition, that's step 1. Right, we know it's a decomposition reaction. Step 2 is to figure out the charges. So we know that barium's charge is a 2+, right? But we don't know CO3. So to figure that out, you are going to have to go to a polyatomic PDF, which I have also included, right? And you'll see that if we can find CO3, might not be on here. I'm just blind. I'm blind. Okay, so here's CO3, right? And we see that it has a 2 negative charge, a -2 charge, right? So then we can go right back here and we can write in, oops, oh wait, oh, dang it. I messed that up a little. And we can write in barium 2+, barium 2+, and we know that CO3 is 2-. So now we're going to break them apart, right? So now after we write in the charges, we're going to predict that product. And the product we know is just a separation. So we just have barium and CO3 carbonate. And then we want to make sure that those charges are balanced, right? So we know that barium has a 2+ and CO3 has a 2-. Right? So that's all good to go. And then we can, looks good, right? Balancing the charges is less important with decomposition reactions, because they're going to naturally balance out. Since you're starting, right, with the full couple, they're going to naturally balance out as the singles. So we just want to double check that everything is balanced, right? We have one, for step 5, we have 1 barium, 1 barium, 1 CO3, 1 CO3. It's all balanced. So our final equation is barium carbonate Again, if it is in parentheses, it's a polyatomic. It's going to be different, right? Turns into barium plus carbonate. Okay, does that make sense? So let's try this next one. So in here we have iron hydroxide. Remember, parentheses, this is a polyatomic, right? So we're gonna determine the charges. So this is where things get a little bit more complicated because we know that iron is a transition metal, so it doesn't have a natural charge. Let's just double check that so I can prove that to you. So we're gonna look for the charge on iron, and we see that it has no charge, right? It's in this unknown section. We still need to figure out that charge. And while we're here, let's just jump over and see that OH has a -1 charge, right? A -1 charge. Hydroxide has a -1 charge. So we're going to go back here. We're going to present, turn all our notes back on. So we know, right, that hydroxide is -1, but we don't know what iron is. But you must work backwards, right? So, and we can do that. So if you take this 2, right? Because that 2 used to be up here before we did our little crisscross. So this is doing the opposite of synthesis reactions. We know that hydroxide has a -1. We don't know iron, but since this is 2, iron is going to be +2. Because you have to remember that crisscross happened at some point, right? So we have determined the charges. That's a little bit harder. We've done step 2. Step 3, we're going to write out our product, Fe, and then OH, or Fe and hydroxide, right? We know balancing the charges, again, not that important. Figuring out them might be a little bit more difficult. And then we want to make sure our equation is balanced. So we have Fe, OH2, iron hydroxide on one side, and we have iron, Fe, and OH over here. So on this side, we do have 2 OHs, right? So that means that the 2 needs to go right here, and we just have 1 iron on both sides. Balancing these equations should be pretty easy. So this is all balanced and good to go. Woohoo! We are going to do one last example. Okay, so this is Al2O3, right? So again, right, we see that Al, we don't necessarily know that charge. Oxygen, we know that charge, right? But if you want to just get really quick, really fast at this process, you can just do that crisscross, right, to figure out the charges. I am jumping ahead from step 1. We are assuming this is a decomposition reaction. We know that because it's already a couple, right? So we're going to go into 2 singles. So we're crossing that out, right? Oops, sorry. Ignore what I just said. Step 1, it's a decomposition reaction. Step 2, we're trying to determine the charge, right? And so to determine the charge, we're just going to do the opposite crisscross. In other words, oxygen's charge is 2, -2, because it's a nonmetal, and aluminum's charge is 3, +3, because it's a metal, and we got that from swapping those, right? So that's a quick way to determine the charges. And now we're going to break it down into our 2 products, right, which are aluminum, these are the singles, and oxygen, right? So we figured out our charges. We break this down to aluminum and oxygen. And then we predicted the product. We're going to check the charges. Everything's good to go. And we're going to balance that equation. So because we started with aluminum 2O3. We're going to go to aluminum. We need to have 2 aluminum, right? Because there's 2 over here. Plus 3 oxygen. That's super easy to balance. That looks like 30, but it's not. It's 3 oxygen. I guess I could write that in. It's all balanced. Okay. You're good to go. Okay, so next time we will work on single replacement reactions. It does get a little bit more complicated, but it's the same basic process, right? You're recognizing the type of reaction, you're writing in the charges, you're predicting the product, you're checking the charges, you're balancing the equation. I know that some of the charge stuff seemed unnecessary with the decomposition reactions. It's just important to stay with the same steps because it will help you stay consistent in predicting all the products. Okay, so you should make sure you fill that into your note sheet, right? And you should make sure that you do those. I think there's about 5 practice problems. In the next class, we will finish up learning single replacement, double replacement, and combustion. And combustion is a lot easier than any of the other ones. Okay, reach out with questions, reach out to your friends for help, etc.